Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge. Minimum distance between BST nodes. So we have a binary search tree, like here. And the goal here is to return the minimum difference between the values of any two different nodes in the tree, right? So the minimum difference between any two values. If we take a look at this one, it's going to be the difference between 2 and 1, right? Because that's 1. If we try any other two pairs like 2, 4, 4, 1, 3, 6, 6, 4, 6, 1, all of them are going to be bigger. So we want to return the difference value, so we return 1. So that's roughly the idea here. Okay, so how can we approach this problem? So the problem says that we have a BST, right? And the property of a BST is that basically the left side, the left node is smaller than the node value, smaller or equal, and then the right node is also bigger or equal. So basically 1, 2, 3, this one is valid because 1 is smaller, 2, 3 is bigger than 2. But something like 4, 2, 8, this is not valid, right? And even 4, let's say we have 2 here, but we have 3 here, this is not valid because 3 is smaller than 4, right? And so that's the property of BST, and what this gives us is that if you do in-order traversal for a BST, you get a sorted list, right? So if we take a BST like 2, 1, 3, and we do in-order traversal, which means basically in-order traversal is just doing the left subtree first, and then the node, and then the right subtree. So if you do this, basically it means you get here 1, 2, 3, and this is a sorted list, right? Okay, so why am I talking about this in-order traversal thing? Because let's say we have a list like this. List like 1, 4, 8, 12, 18, something like this, right? So for a list like this, actually, to get the minimum difference, which is what the problem asks us to do, you only need to compare adjacent values, right? You don't need to compare, for example, 4 and 12, 1 and 18, right? That's not necessary because these closer values have a smaller difference between each other, right? And so that tells you that if you take ones that are more than one distance apart, then you will get a higher difference than if you just take adjacent ones. So it makes sense to only compare adjacent ones. And comparing adjacent ones will give you can be done in O(n) time, right? We can just compare each I with I plus 1, and we just do for I from 0 to n minus 1 or n minus 2, right? And that should be enough. And so what this tells us basically is that there is an approach to solve this problem where we could just do the in-order traversal to get a sorted list, right? And then once we do that, from the sorted list, we can get the minimum difference using just of n scan, right? So basically get the min difference, okay? And doing the in-order traversal itself, that's just of n time, right? Because we'll go through each node to get the sorted list. And once we get the sorted list, this is also just of n scan, what we said here, okay? So overall, we have of n time, but we have this sorted list that we need to generate. And so at the same time, we have of n space, okay? And so what we'll want to try to improve is of n space, right? What we want to try to improve is this on space, get it down to O(1). How can we do that? Well, instead of generating the list, let's just do the check that we are doing here with adjacent ones. Let's just do it in place while we are doing the in-order traversal, right? So how do we do that? Well, for each element, let's say 4, we only need 1. For 8, we only need 4, right? So for each element, we only need the previous processed value, right? So for example, here when we are comparing 2, we only need 1. When we are comparing 3, we only need 2. So you can see here, for 2, we only need 1. For 3, we only need 2. So for each one of them, we just need the node that was previously traversed. So for each node, when we are doing the in-order traversal, we only need the previous node that we previously traversed so that we can get the difference and check if it's the minimum difference. And that should be it. And so if we do that, then we just need to keep track of the previous node for each node, and then each time calculate the difference, and that should be it, right? And so let's apply this to an example and just make sure we do understand it. Okay, so if I do that here, so what we said we need to do is we need to keep track of the previous node. And so because we are going to do this across all traversals, let's just put it in a class variable. And then we need our result, which is going to be the min difference, right? So let's call it min difference here. Initially, we'll just put it at a really large value like infinity. And self-prev, we can just put none because when we are at the first node, there is no previous element, right? Okay, so now we do our traversal. So we want to do in order, so we keep going left until we reach the leaf node. That's when in order traversal does. And so the first node we are going to process is 1, okay? And so the node we are currently processing is 1, has a value of 1. And so when since there is no prev, we don't need to compare any min difference, because there is, just like with the array for 1, we don't need to compare it against anything, so we stop there. And then when we go to so the in order traversal is left node and then right, okay? So we go to the node 2, so now our node is 2. Before going to 2, we will need to register that the previous one we just visited is 1. So we need to make sure to register that. And now we do, the difference is just 2 minus 1. 2 minus 1 is 1, better than this infinity, so we just put 1 here. And now we go to the next node, but we need to replace the previous value with 2 because that's the previous node. And now here we have, in the node value, we are at 3. And so 3 minus 2, that's 1. So we keep 1, it's the same. And now we replace our prev to 3 because we now go to the next node, which is 4. Remember, it's left. We finished the left side of this 4. And so we go to the node itself, 4. So now the node is 4. And the 4 minus 3, the difference is 1, so that's good. Again, we replace prev now with 4, and we go to the 6, because that's the right, we finished the node, so we go right. Okay, so now node is 6. 6 minus 4, that's 2, but 1 is better than 2, so we keep 1, right? And now we are done because we are at the last leaf node. And that's pretty much it, right? So pretty simple solution once you understand in order traversal. Now, what's the time complexity here? Well, you can see here we used only these variables, but for the traversal we traversed all the nodes, so it's O(n) time, that didn't change. But for the space here we are using only variables, so it's O(1) space. Okay. Yeah, so that's pretty much the idea here. Now let's implement it. We need to define our DFS function, right? And of course, if not node, we just need to return. But we also need our min diff, right? Which we said initially we'll just use infinity, right? So that if we min with anything, we'll get that value. And then we need to start the previous one. So initially it's none. And then we start our DFS on the root, and we want to return the min difference after that, okay? So this is what we want to return. Then what we need to do here with our DFS is we said we need to do DFS first on the left side, right? And then we need to do it on the right side, like that. Okay. And we need to get two things, right? We need to get the result, and we need to get we need to update the min difference, and we need to update the previous. So each time the previous is going to be the node value, right? Because when we traverse a node, for the next iteration, so for the right side, we want it to have as previous the node value, right? And so here we also want to get the min. This is going to be the min of self.min diff, and the difference between the current node, right, and the previous one. And so that's just going to be the value in previous value. Okay. And that should be it pretty much. So we traverse the left because we want to go all the way left. So that we start with the left side. we update our min with the current node and the previous one, and then for the next iteration we want to make the previous value be the current node, right? And then we go to the right side. And want here, so we want to for the first value we want the difference to not be just that value to not be the min. So what we can do is actually just initialize this to minus infinity, because then no matter the value of the node, the minus of that pref will give you an value math dot infinity, which will be really big, which means the minimum of the next iteration between the first element and the second element will give us the minimum, the actual minimum, right? And so this is just to not need to do that extra check. We can just initialize to minus inf. So if we do that, submit, this passes our test cases, right? Yeah, so pretty straightforward once you understand in order traversal. Please like and subscribe, and see you on the next one. Bye.